Welcome to Study Loop.
So in this problem, we are given with the reaction equation for the reduction of iron oxide or iron ore with carbon monoxide, which gives us iron and carbon dioxide gas. And it is said here that at the time of Chatelier, it was concluded that in the expense of a very huge amount of money that um, the reduction of iron ore by carbon monoxide is a limited reaction. And first, it was thought that uh, the the limited reduction of iron ore by carbon monoxide is due to the prolonged contact between these two reactants, and that's why they increased um, the size of the reaction vessel. And even after doing that, there was not much change. That means still the amount of the products are almost same, and the reaction was still limited. And we are asked to find out the same conclusion based on the chemical equilibrium theory, and we can easily do that by just forming up or setting up an expression for the equilibrium constant for this reaction. So if we write down the equilibrium constant Kc for this reaction, it will be the gaseous products concentration over the gaseous reactant concentration. So the gaseous product here is carbon dioxide. So on top we will have the concentration of carbon dioxide, and since it has a coefficient of 3, we'll have to raise the power by 3, and in the denominator we'll have the gaseous reactant concentration, which is carbon monoxide. And again, since it has a coefficient of 3, that means its power will also be increased by 3. Now from here you can see that the equilibrium only depends on the concentration of the gaseous components, carbon dioxide and carbon monoxide. And if we look at their coefficient, both of them have a coefficient of 3. And that means we know that from the Le Chatelier principle that um, a reaction equilibrium will shift um, in either side, increasing the volume if there is a difference in the number of molecules or the coefficients of the gaseous reactants and products. So, of so if we have, say for example, uh, four gaseous molecules in the product sides and two gaseous molecules in the reactant sides, and in that case, if we increase the volume, that means increasing the volume, the equilibrium will shift it in a way where there are more number of molecules present. So in that case, since we have four number of molecules in the product side, the forward reaction rate will increase and the equilibrium will shift to the right. And if we decrease the volume, it will go the other way, because if we decrease the volume, that means the equilibrium will shift in a way where there are a lower number of molecules present, and in that case, the equilibrium will shift to the left. But since in this case we have uh, three number of gaseous molecules in both the sides, that means increasing the volume will not change the rate of forward or reverse reaction. That means whatever the volume of the reaction vessel is, the reaction rate will be same for both the forward and for the reverse reaction. And that's why increasing the um, increasing the volume of the reaction vessel did not um, increase the amount of the product, or did not increase the rate of the reduction of Fe2O3. And that's how we can conclude from the equilibrium theory that since the changing the volume will only affect the reaction when there is a difference between the number of molecules in reactant and product side, and if the number of molecules in reactant and product side the number of gaseous molecules in reactant and product side are same. That means the volume will not have any effect on the reaction rates, and that's why in this case um, the reaction rate will not change by changing the volume.